Hi everyone, welcome to our first Math 1 video. This topic is going to address our skill for the day. So what we're going to do is we are going to start with a pattern. We've been doing a bunch of patterns, okay? So this one says, on the first day of Algebra 2, students came up with many different looking rules for predicting the number of stars in any step of the pattern above. Some of their rules work and some don't. Determine which of the students' rules actually work. As usual, x equals the step number. So what I want you to do is I want you to pause the video and I'd like you to come up with a rule or an equation for this pattern. When you have come up with an equation or you feel you've spent enough time and you're struggling, I want you to unpause. Okay, go ahead and pause now. Okay, now you're back, and hopefully the equation you found, what we see is that each time we have a row of 1, 2, 3, 4, 5 being added, and our step 0 is 3. That means that for what we've been doing in class, our equation is 5x plus 3. Okay, so now what I want you to do is I want you to take a look at all of these different answers that the students in Algebra 2 gave. And again, remember, the one we came up with is 5x plus 3, or some of us might have come up with 3 plus 5x, okay? And what I'd like you to do is I'd like you to think about, I want you to pause and I want you to cross out the ones that don't work. So it says determine which of the student rules actually work. If there's any that don't work, you can go ahead and cross those out. So you can press pause now. Okay, now we're back. So when you look at this, which one of these don't work? Well, if you plugged a couple different strategies is I could plug 1 in and I better get 8, right? That's one way to think of this, okay? And so what we notice is that each of these actually, if we look at this, let's see, which one of these don't work? Well, it doesn't look like Dennis's rule works. It doesn't look like, let's see, it doesn't look like Nicole's rule works. And other than that, it looks like everyone else's rule works. Okay. Now, if we look at this, if I plugged, one reason why Nicole's doesn't work is if I tested it with any of the patterns up above, I'm not going to get the answer that I wanted. Okay. Okay, now let's take a look at the back. So if we flip over our page, we see it says cross out the rules that we determined did not work. Okay, so I already forgot. So we determined Nicole and Dennis's rule did not work. Okay, so I'm going to cross Nicole and Dennis's rule out. And then it says, what do all of the rules that work have in common? Why do they work even though they look different? Well, if I look at this, what I notice is that if I have 3 x's and 2 x's, those are what we call like terms, and I can combine those. If I have 3 x's and 2 x's, I have 5 total x's. There's nothing that is a like term with 3, and so that's as simplified as that one can get. And guess what? If you remember from the front, the pattern we came up with was 5x plus 3. Okay. Now this one was just a flip-flop, so that one works. John's works, Mary's works. Now what about Anne's? Let's look at this. If I have x plus x plus x plus x plus x, well, what I can do is I can think of this as, I could think of the x's as apples. If I've got a pile of 1 apple, 2 apple, 3 apple, 4 apple, 5 apple, I've got 5 apples. And the 3, because there's no x attached to it, is off on its own. Now, if I look at Melissa's rule, what I notice is that it is the same as our rule. So Melissa, she's got it going on. Now, Tim's rule, let's look at Tim's rule. So this time we've got all of our x's together, but we have a 1 plus a 2. Now, those are like terms because there's no variable attached to either of those. And so I've got my 5x, and then 1 plus 2 equals 3. So Tim's correct. Now, what about Roger? Roger looks a little bit different. So if I group up the things that are like terms, the things that have x's, and then I think of the thing that doesn't have an x, well, how can I combine those? Well, my x's can be combined because they are exact copies. Those are what we call like terms. So 7x minus 2x. The x's don't go away. Replace x with apples. If I have 7 apples minus 2 apples, I still have apples, but I only have 5 of them. And so Roger's rule works. So what we're trying to get at is like terms, okay? So some examples of like terms are things with x's. So if I have one pile of like terms, I have 5x, I have negative 2x, I have x, I have 1x, I have 3x, I have 0.2x, I have 1/2 x. Those are all like terms because they have a common variable of x. Let's make another pile. Another pile could be 2xy, 3xy, negative 1xy. Now here's a curveball. I could also have 5yx. The order doesn't matter. Okay? It's the fact that I have those pieces there. Now what about this? Is 5x squared and 3x like terms? Well, they both are x's, but they're not exactly the same. That is a 5 in case it doesn't look like it. This has an x squared, and this has an x that's not squared. That means these are not like terms. So you're going to practice this a little today. Practice combining like terms and ordering them, getting everything grouped up into like terms. Imagine taking all the terms that might be there. For example, 5x plus 3x minus 12 plus x squared minus 15x squared plus 5. Well, geez, that's a lot. But what I can do is I can differentiate each of these, okay? I'm going to put circles around my x's, and I always keep the sign with it. No other x's. I'm going to put squares around just my numbers. And then I'm going to put triangles around my x squareds. These look like weird triangles. And then I can group them up and combine them. 5x plus 3x is 8x. Negative 12 was all by itself. Oops, no, it wasn't. Negative 12 plus 5 is going to be negative 7. And then 1x squared minus 15x squared is negative 14x squared. 8x minus 7 minus 14x squared. Have fun practicing.